So let's see the next chapter, chapter 13 of the physics. Topic name is magnetic effect of electric current and magnetism. Chapter 13, magnetic. Right. Next is magnetic effect of current. Magnetic effects of current and magnetism. Right. So see the first question, which is based on magnetic effect of current. It is asked in 2021. So a uniform conductor of wire length is given, that is length of this wire is 2A and resistance is given R. Is round up as a current carrying coil in the shape of like first is in equilateral triangle. First in is in equilateral triangle, right? And second one is in the square form, the square side, right? So see the length of wire is given, that is how much it is was 12A, right? So it is not 2, it is 12. Right, resistance is R, current is I. So for the equilateral triangle, side is A. And so magnetic dipole moment for triangular coil will become, so see the second part of it. So it will be M equal to NIA. So say M is nothing but it is your magnetic dipole. Magnetic dipole, right? So when number of turns in the triangular coil will be equal to N equal to 12A upon 3A. Why it is 3A? Because three sides in triangle, right? So it is divided by 12A divided by 3A. Then it will be coming out to be 4. And as we know, I equal to V by R. And we know the area of that equilateral triangle, that is given by root 3A upon 4A square, side square. So this is the area for equilateral triangle. Then your magnetic modification field will become M1 will be coming out to be, so number we know that is 4 now. So put here 4, right? So I value we know, this is your I value. How much? It is V by R, right? So put this value, that is V by R. And we know A now, area. So area is nothing but it is root 3 A square upon 4. So it is root 3 upon 4 A square. So its answer will be how much? After arrangement, this 4 and this 4 will cancel it out, right? So it will be root 3 A square V upon R. So this is your one magnetic dipole moment 1. Now see for the second part, that is a square. Then it is your M2. This is nothing but it is equal to N2 IA2. Right. So N2 we know that is 12A upon 4A. Why 4A? Side of the square is 4, right? Next is current, that is V upon R, and A2 we know area of the square is A square. So M2 will become what? This A and A will get cancelled, right? And cancel this part also. 12 is divided by 4, so it will be 3. So it will be 3V A square upon R. So this will be the answer for that. So as we know that M1 and M2 now, this is the magnetic dipole moment for the square. Magnetic dipole moment of square, right? So please remember this basic general formula for magnetic dipole moment. Magnetic dipole moment. right? So where N is number of turns and I is your current and A is your area. So please remember this one. Now look at the question number second. Second is iron rod of sustainability is given 599. Iron rod whose sustainability is given as 599 is subjected to a magnetizing field. So whose magnetizing field is given as 1200 ampere per meter, right? So the permeability of the material, we have to find it down. Permeability, right, of material. Mu naught is given, that is 4 pi into 10 raised to 7 Tesla meter per ampere. So see the sustainability symbol is XM, right? And we know the relation between that permittivity. So permittivity is given by mu r. So we know the relation between them. So it is nothing but mu r is equal to 1 plus xn. So mu r is coming out to be 1 plus 599. So it will be 600. Mu r means permittivity, right? Now see the next part. You have to find the mu. So mu is nothing but it is your mu naught into mu r, right? So mu naught value we know, that is 4 pi into 10 raised to minus 7. So it is 4 pi into 10 raised to minus 7 Tesla meter per ampere into mu r value we know, that is 600. So it's coming out to be how much? 2.4 pi into 10 raised to minus 4 Tesla meter per ampere for the mu, right? So this is the relation between them. Now see the next sum, third one. So let's see the third, a solenoid of 50 centimeter long. So there is a compound whose name is solenoid, whose length is 50 centimeter. Having turns is 100 given, carrying a current I equal to 2.5 ampere. Magnetic field, we have to find it down, B, right? So see the explanation for that. So magnetic field of the solenoid is given by B is equal to U naught N I, right? And we know N relation. So N is small n is capital N upon length, right? So N is nothing but it is number of turns by length, right? So it can be, so it is 1000 divided by length is given, that is 50 convert into meter, then it is 10 raised to minus 2. So it is coming out to be 200. How you have calculated this? Minus 2 will go up, right? So it will be 100 into 100 divided by 50. So this is cancelled with 2. So 200 we are getting a small n. Right, now put in the formula. So you will get B. So B is nothing but mu naught value we know, that is 4 pi into 10 raised to minus 7. N value we have got, that is 200, and current is given, that is 2.5. So multiply with that, you will get B. So B is nothing but 6.28 10 raised to minus 4 T Tesla. Have you understood this one?
Yes, sir.
See the question number 4. Magnetic flux linked with the coil is given by flux is given by 5t square plus 3t plus 16. So this is your flux part given to it. It is asked in 2020. So let's see. So as we know, magnetic magnitude of induced EMF is given by. So when we have to find EMF, right? Electromotive force. So it is nothing but differentiation of flux with respect to time. So value of phi is given, this one. So I will put here 5t square plus 3t plus 16. So this value we have to differentiate with time. So it will be 5 into 2t plus 3 and t power is 1. So it will be 1. Constant is 0. So it will become 0. So your answer is 10t plus of 3. This is your EMF depends on time. Right. So now we have to put the value t at 4 seconds. We have to find the EMF. So E will be 10 into 4 plus of 3. So it is 40 plus 3. So it is coming out to be 43 EMF. Understood?
Yes, sir.
Okay. Let's see the next sum, that is fifth one. Fifth one is cylinder conductor of radius r is carrying a constant current. Plot of the magnitude of the magnetic field with the distance r from the center of conductor is correctly represented. So see, still talking about cylinder conductor is given whose resistance is r, right? Constant current, that is I. Plot of the magnitude of magnetic field is given, that is b, with the distance d from the center of conductor is correct is given by. So see the formula for magnetic field. It is given by mu naught upon 2 pi I into d upon r square. So we know b equal to kd. So this is your k value. Which one? This whole part is your k. So k is nothing but it is mu naught I upon 2 pi r square. So it is your straight line, like y equal to mx. So your graph coming out to be a straight line first, right? Up to r. Then we know the magnetic field through origin straight line is given by. And for the maximum value, like when d becomes greater than radius, then your b is coming out to be mu naught I upon 2 pi d, right? So b is here inversely proportional to distance, right? Here it was directly proportional. That's why straight line is there. So this is straight line, right? And this is the inverse graph. Inverse graph. So it will be like this, right? So this is the graph between B and R. First it increases. So this is your increasing graph. This is your decreasing graph. So please write it down. Now see the question number 6. So ionized hydrogen atom, right? Hydrogen atom is ionized, right? And alpha particle with the same momentum. There is alpha particle, right? Whose momentum is given to it, momentum, right? Enters perpendicular to the constant magnetic field, that is B. So it enters to the B, that is magnetic field. Magnetic field. So it is asked in NEET 2019. So let's see how radius is related. So radius of hydrogen is given by rho upon EB. This is your E part. Similarly, for the alpha particle, radius is nothing but R alpha is given by rho upon 2EB. So we know the relation between them now. Divide 1 by 2, then you will get the relation RH upon R alpha. Rho by EB divided by rho by 2EB. So it is coming out to be, this rho and rho will get cancelled and EB will get cancelled. So it's coming out to be 2 upon 1, right? So this is the relation between radius of hydrogen atom ionized and alpha. Let's see the next part, 7. Question number 7. So it is, at a point on the Earth's surface, the angle of dip is given by. So angle of dip is given by this part. This is like this. That is plus of 25. At a point B on the Earth's surface, angle of dip is given, that is minus of 25 degree. Right. So this is called angle of dip. Right. We can, what we can interpret it. So angle of dip is the angle between Earth resultant magnetic field from horizontal angle of dip is 0 at equator and positive in the northern hemisphere. So angle of dip, C, it is the relation between magnetic field horizontal and magnetic field vertical, right? So this is given by like this. So when angle of dip is positive, so this will be the graph for that. And when it is your, this is magnetic field vertical, this is magnetic field horizontal. So angle of magnetic field dip is given like this. So it is also here positive. Right, for the northern hemisphere. So it is for northern hemisphere. Right. Now for the southern hemisphere, the angle is considered to be negative. So please write it down, these two graphs. For southern hemisphere, angle of dip is negative.